Alright, in this video we're going to take a look at lab 14. Now there's a lab 14 directory, and there's my program that I worked on today. Started with what we had in class, and here it is. There's Q to quit. There's plus and minus for speeding up the simulation. So you can see the speed going up and down. There's a T for put a trail on. There is an F for doing fast calculation. P for pause and play. S for saving this as a text, which would have saved into a text file. On the bottom here you see a count up of the total number of seconds that have elapsed in the simulation. This here shows the scale that I'm currently at. So if we go in here to where Earth is about 1 character from the Sun, that's 95 million kilometers, and that is about how far the Earth is from the Sun. So it's just kind of a dummy check. So as I go in and out, that's showing the scale. This here is showing how long it's taking to actually do the redraw calculations. If I turn off the fast mode, you can see that that has gone up to about almost 1/3 of a second. And the speed here, I'm pressing plus, but it's not going to do any more once that goes over 0.2 seconds. Okay, there's also the arrows. Turn the trail off, so if I need to recenter because things have gone off screen or something, the arrows will move that around. We also have 2 other systems here. This is the one that was suggested in class. And this one is one that, just based on where I put the planets initially, it does want to kind of go off screen. You kind of see that if you watch the trail for a little bit. Speed things up even more. Things are slowly going down. So, right, whatever's happening there. Looks like I zoomed out too fast there. Yep. Alright, so this is another one here. We could do let's put the trail on. Take the trail off. Okay, let's get this centered again just to kind of get a nice picture. Yep. Yeah, that makes sense. Okay, we'll get out of there. Alright, so all you have to do is all of that. Just kidding. Those are all options of things that you could do, and I updated the document here to, there's some notes about the different options, and I just picked at random the number 3, do 3 of those. So you make a directory, homework lab 14, copy in version 2, that's the version that is from the last video here. And then these are all things that I did, and pick a few of them to do. So the first one is to look at this system. And put this system in, the parameters for this system. So I'll go ahead and look at the file that's the version 2 that you'll be starting from. So in version 2, this is the solar system. We have the sun, our sun, which is this many kilograms. Mercury is this many kilometers from the sun on average, and is this many kilograms. So we could go to this this system here. The star here is estimated to be 31% the mass of the sun, so you could put that in there. And then the planets are estimated to be, okay, 1.7. This is 1.7 times the distance. Sorry, that's the mass. So 1.7 times as massive as the Earth. So you could compute that. And then the distance, much closer than the Earth, 0.028. All right, and you can use these letters as the display characters. And if you do colors, these are the colors that I used. Yellow for the star, and then the same order of colors as for our solar system for the color part. All right, so you could just change the, you basically need to put that stuff in here. And you can run mine against it just to kind of get a rough idea. All right, add P for pause and play. If we go to planets here, right now we have a get ch, and it's doing a queue. So this part right here is the part that is actually doing the computation. And if we want to pause the movement, then this is the part that we would only do if we're not paused. So you could check this. You could check this character right here directly to see if it is a P, or you could set a flag inside of the input and then do something with it, however you want to manage that. All right, let's go back to assignment. S for save. So if we're running the simulation, so I'll run mine here. If we're running the simulation, then we could pause it at some point and press S for save. And then if I look at that image, it's called planets capture. So there it is as text. And the way that, there's a couple different ways you can do this. The way that I did it was using in.ch. So there's a get max yx that the Kurtz's call to say how big the screen is. And then there's an in.ch that'll read characters. That's basically just nested loops to read for a given row. You read across the column and then you read down. So there's be nested for loops for each row from 0 down, and for each column from 0 over. Okay, color. So first step in doing color would be to use a black background and a yellow for the text. And I think there's an example at this link here. This pretty much has everything that you would need. You have to call start color, you have to initialize a pair, and then you have to do attribute on, and that will actually turn this color on. So this one here matches up with this one here, that it was initialized to be red and black, and then that was turned on, and that's until you go to a different color or you have the attribute off. Alright, so first step would be just to put in basically this stuff before in the initialization of the curses stuff. So we had init curses, and then we would do some more stuff about colors there. Okay, that would be first step on colors. Second step on colors would be to put different colors on the different planets. And the way that I did this was going in my objects.h. So each object has a mass, a position, a velocity, an acceleration, and a character. So I would add here int color code or something like that. And the color code, I would have one for each of these. So I'd say 1 is going to be yellow bold, and I would set that up with a 1 yellow bold. Dark gray didn't actually work for me, but that could have a 2 for whatever I'm doing for Mercury, 3, 4, 5, and so on. So each of those would get some color code. And then I would have a place to store that in the object, and then I need to make sure that it gets in there. And the place that gets created is this add object. So here I have the XY coordinate, the character, the mass, so I would have to add something here to pass in color code. And then I would have to add that to the list of parameters here, so then I can put it into the object, and then so that I can use it when I draw. Right, this is my draw function. This is getting out the X and the Y coordinate. It's getting out the display character. I would also then do something with the color, but I would have to store that in the object. Or you can think of some other way to do it. So the goal is to get different colors on all these different planets. Okay, display of how many seconds have elapsed. So here we're doing a update. So inside of the update, so add a double in the world T to keep track. Do 0 initially, update in the update function, and display in the draw curses. So the update there, that is where we're doing the having the objects move forward a little bit, and inside of that there's a time step. Okay, add keys to zoom in and out. Those are going to have to be handled inside of this input function, and then so you're going to have to add them to the input function and then somehow use that in the draw curses. Draw curses does a scale here, so that's dividing to fit things on the screen. So you're either going to change that scale or do something else. So that would be, you need to handle the characters. I was using less than and greater than. You could use something else in your input. World T : input, and then use that. Probably the best thing to do is use that to change the scale. So for example, if you do less than, we'll maybe times equals 2 or something like that, and greater than would be divide equals 2 on the scale. Adding the keys to shift left or right is going to be similar. You need to handle some characters to do that. You need to handle the arrow keys or some other ones. You could do WASD if you want. Of course, that S is already used for something. Handle the arrow keys and use those. Let's see. When pressed, update some variable in the world T object that is used in the draw curses. So the way I was doing it was I had some variables that I simply add to the row in the column. So there's some variable that I have called offset y, and my row is like a y coordinate, which row I'm on. So I just add offset y, and in the input, if I see that I have an arrow key, which you can look up how to do that, there's a code for it. Then I would just change my arrow key. Looks like we already have this scale here, so I guess that's all right. Add a trail on each object so we can see the orbits. That's going to do something with the draw curses, because right now the draw curses does a clear. We would want to not do a clear. So don't clear the screen in draw curses. Instead, something else. Having at least 2 different solar systems to choose from. Right now, there's a comment here to either do load our solar system or something else. You could have 2 different versions of that, and then you check the arguments to decide which one gets loaded. Fixing a bug in the velocity calculation, I'll let you read that if you want to look at that. And same thing with number 11, if you want to read that, you can. I feel like there was one other thing. Let's go back to the fast calculation. Did we have that in there? Yeah. Fast calculation mode. So add a setting to do that or not. So for fast calculation, compute G just has a loop for I, and then uses the center of mass. So this would only, I mean, you only want to do this if you're pretty okay with what all these equations, where they're coming from. So right here we have, for object I, we're going to figure out what's the gravity between all the other objects and I. So that makes this kind of like a quadratic running time kind of thing, that if we have 10 objects, there's 100 different times we run this code inside of here. If we have 20 objects, it's going to be 400. So it's not good that it's quadratic like that. So to make it a little bit faster, instead of iterating over all of the other objects, we could just take the center of mass that we calculated in the beginning, which is in variables called, the location of the center of mass is in a variable called center. The mass of the solar system is in a variable called mass. Or you could just use the sun for this solar system, since the sun is most of the mass. So if you just do these equations for, instead of doing stuff bracket J, you just do the center of mass. It'll be faster, and that's the fast mode. Alright, so those are all your options. We'll see what you think. Have fun.